example comes out of section 3.1, velocity. So somewhat similar to our first example, we're given a position-time equation. This one must not just be a book falling off a building, it must be some kind of particle accelerator, because we've got a strange position function, 4t cubed minus 42t squared plus 120t equals s. The velocity after 4 or 5 seconds, we just need v equals ds by dt. And so when I take the derivative of this thing, I get 12t squared minus 84t plus 120. So to figure that out after 4 seconds or 5 seconds, I'm just putting in a 4 and a 5 there. So the velocity after 4 is going to be equal to, and the velocity after 5 is going to be equal to, and I'll just crunch those numbers. And so just putting in the numbers there, put in a 4 into this function, I get 12 times 16 minus 84 times 4 plus 120, and I get negative 24 meters per second. And again, they would have told us meters and seconds in the question in the book. If I put in 5, interestingly, I get an answer of 0, which means that if your velocity is 0, it means your particle just came to a stop, or it's at rest at that instant, which actually is interesting because the next question actually asks us, when is our particle at rest? Well, it's going to be at rest not only at 5 seconds, but anywhere else where this happens to be 0. So v equals 0, 12t squared minus 84t plus 120. You can see where these numbers got chosen. They're somewhat artificial in that they factor so nicely that we end up with t minus 5 and t minus 2. So at time equals 2 seconds and time equals 5 seconds, this particle's at rest. And we already knew the 5 from what we just did, just by coincidence, but we also found that at 2 seconds this thing stops. Now when is it moving in a positive direction? It's just when is velocity going to be greater than 0. So if I take that same function and maybe even just take the factored version of it, 12 times t minus 5 times t minus 2, and say when is it greater than 0, really this is where we've practiced this a little bit before. We know it stops at 2 and 5, so it won't be positive at those points, and we're only starting at 0. So I pick a number to the left of 2, and I could even pick 0 if I liked, or 1, and I find out that I've got 12 times a negative, which gives me a positive. So this thing is moving in a positive direction everywhere from 0, 0 up to, and not including 2. Is part of my answer. Now if I pick a number between 2 and 5, I'm going to have a positive, and 12 times, let's say, negative times a positive, so I've got negative, and definitely that, during that time this thing's moving in a negative direction. If I put in a number greater than 5, I'm going to have positive, 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 and so this thing is definitely moving in a positive direction when t is greater than 5. So we've got 2 time intervals from 0 to 2 and from 5 to infinity. This thing moves in a positive direction. Now, total distance in the first 8 seconds. If you make the mistake of just putting 8 into the original equation, you'll have the position after 8 seconds. But as we just discovered, this thing from time equals 0 to time equals 2 moves positive. Then from time equals 2 to time equals 5, it moves negative for a little while. And then, from 5 to 8, and from everywhere thereafter, it moves actually in a positive direction again. And so your position is not going to be the same as your total distance. To find the total distance, we need to find the position at these separate little spots here. So at time equals 0, turns out position equals 0, so that's a nice easy one. At time equals 2, I need to put a 2 into the original equation there and figure out what that is. I get position of 104 meters. So far, if we're totaling up our distance over here, we've got 104 meters. Now we'll add that to how far it travels in this next little bit. So at t equals 5, I need to find a position. And I find a position of 50. So it went all the way from 104 to 50, which means it actually traveled 54 meters. You just find the difference in those positions, and you don't worry about the fact that it traveled in a negative direction, because we just want total distance, which doesn't matter if it's positive or negative. Now finally, the last one, I figure out, well, where is it going to end up here when time equals 8? So I get a final position here of 320 meters, which means to go from 50 to there, I had to travel 270 meters. So if I total these up, I find a total distance traveled of 428 meters. Not complicated in terms of the fact that you're adding and subtracting for most of that, but mostly visualizing what this thing's doing, that it goes forward, then backwards, then forwards, and I have to add up those separate distances. Makes that question a little bit trickier than the previous one.